Hi guys, it's a guy Olumde, and today we'll be solving another one of the most commonly asked tech interview question. It is the graph deep copy, and it's a DSA problem that's commonly asked by top tech companies including Google, Amazon, Netflix, Microsoft, Meta, Apple, and other top tech companies. The problem statement states that giving a reference to a node within an undirected graph, create a deep copy if the graph of the graph. So we are going to be giving a reference to a node, and we are asked to create a deep copy, a clone of the graph. The copied graph must be completely independent of the original one. So this means we need to make a new node for the copied graph instead of reusing any node from the original graph. So we are given this example graph, so which is actually this graph we can see here, and we are given this cloned one, which is the a real replica of the original one, but a very different and unique node, new node. So all nodes are deep copies, no reference to the original node. So we are given some constraints now, and the one is that the value of each node is unique, right? And the other one is that every node in the graph is reachable from the given node. And why we are giving that particular constraint is because, don't forget, we'll be giving a reference to a node, a single node within an undirected graph. And now this constraint is now making it clear to us that every node is reachable from the given node that will be given to us, right? So we don't need to be bothered about, oh, what if we can't reach this? What if we can always reach each and every node from the given graph. Our strategy for solving this problem is to traverse the original graph, and as we traverse from node to node, we are going to create a deep copy of each node we come across and try to mimic the relationship as we traverse the original graph. Any traversal method, we discussed in our previous video that we have two major ways of traversing the graph: the DFS, the depth first search method, and the breadth first search method, right? So we will be focusing on the depth first search method to solve this problem, which is the recursive method that requires us recalling the function again and again, even though any method at all could work to solve the problem, but we will focus on the depth first search method. Now, to solve the problem by traversing the graph, we will call DFS on the root node, or let me say on the given node through which we can reach other node, right? So we are gonna be calling DFS on it, and what we want it to do is that we want it to create a copy of that particular node with that particular value, right? So we want it to clone that node, and we also want it to create a copy of the neighbors of the same node, right? So that we can mimic that relationship, because for this particular node now, it probably will have neighbors, which in this graph you can see that it has the neighbor 0 and 1 and 2. 0 have the neighbor 1 and 2, right? So we will want to create this neighbor as well and to attach them as neighbors of 0, so that we can effectively clone the graph. Now that we have created the node, we have cloned the node by creating a new node of the same value as 0. We want to make sure that this cloned node mirror the original one by actually cloning all its remaining neighbors in the original node, and then attaching it as a neighbor in this same cloned graph that we are building. To achieve this, therefore, we are going to call DFS on each of the original node's neighbor. This original node 0, we are going to call DFS on each of its neighbor, meaning that on the neighbor node 1 and neighbor node 2. So, and that's what we did here. So that way we'll be able to effectively clone them as a, we are going to be effectively be able to create their clone and attach the clone there as the neighbors of the node 0. And that's what we did right here. So we say that a call to DFS1 also will return node 1. Why? Because what we are actually doing is that what our DFS is doing is that it's gonna collect that particular node and create the node. It's gonna create a new node with that value. right? So that way, after creating it, you can now return the node as back as a neighbor to node 0, and similarly a call to DFS of 2 will create the node 2 and return it as a neighbor to the node 0. This is what the DFS function will look like. It's gonna collect a node, right? It's gonna clone the node by creating a new graph node with that particular value, and after cloning the node like that, it's gonna iterate through the original node neighbor, and it's gonna call DFS on each of these neighbors so that it can clone them as well, just like it cloned this. And after collecting their clones, that's why I said each of the call will also return the cloned node, right? So what we do is that we now collect that cloned node as this variable here. So each DFS call will actually return the cloned node, and we are going to collect it as the cloned neighbor here. And after that, we can now say clone node, which is this original node here, dot neighbors dot add cloned neighbor. We are going to be adding that particular cloned neighbor as a neighbor to this clone node, so that we can effectively create that, mirror that relationship, that neighbor relationship. And after doing that for each and every node in the original node's neighbor, so we're gonna return this cloned node now, having created this neighbor, having cloned its neighbor and attached its neighbor into in place by adding them to the neighbor attribute, which is actually a list, an array that we add the cloned neighbors to. So after doing that, now we can now return the cloned node. One thing that we should also be mindful of is recloning or cloning neighbors that have already been cloned. What I mean by this is that let's consider this particular node. Let's consider node 2 in this original node, this original graph, and the cloned graph. This is the clone graph here. So considering node 2, you say that node 2 have node 0 and node 1 as neighbors, right? Now let's say that we have node 0 and node 1 already cloned, and now we are trying to clone node 2, and after trying to create an instance of node 2, we are gonna try to clone its neighbor and add each of these clone as a neighbor to the cloned node 2, right? So but because we have cloned this neighbor before, we might make a mistake of actually in order to clone them. What do? We call DFS on each of these node 0 and node. So okay, there's supposed to be a node this particular node here to node 3, right? Because it is there in this particular function. So let's just do something like this, right? So now because we just created and cloned this node 2, we want to iterate through its neighbors so that we can get them cloned as well and get them returned, so that we can actually add them to those 2 neighbor attributes, right? So and therefore to do that, we're gonna call the DFS function on node 0 and on node 1, right? So and also on node 3. Oh, sorry, let's quickly do this. I just want to make it more understanding in visual. So we do something like this, right? So something like this. So we are gonna call the DFS on node 0, then on node 1, then on node 3, so that we can get them cloned and get them returned, so we can add them to as a neighbor of node 2, just like I explained in this code here. So right now, but if we do not actually undo the previously cloned node, what we are going to be doing is that we are going to be creating, or let me say recreating, the already created node 0. Don't forget that we are currently at node 2 and we have cloned node 0 and node 1 already. So having to reclone node 0 and node 1 by a call to this here will result in an error. Why? Because no, we don't want it to be a new node. We already have the node existing before, so we just want it to return this existing node that have been cloned, right? So instead of having to create a new one, and because of that, when we perform a call to an already cloned node, so what we want to do is that we want it to return that node that has been cloned instead of creating a new one. So meaning that at this point whereby we perform a DFS call to node 0 and a DFS call to node 1 and a DFS call to node 2, if it existed before, meaning that if the clone node exists, we just have to call it to return it, instead of having to create a new clone node and keep on creating. Don't forget that in the process of creating a new node for 0, we are going to have to create for its nodes to its neighbor node 2, and that will just keep on resulting in an infinite loop. So but because node 0 have been created, we can actually reuse it, that cloned one, instead of having to recreate it. And how we can solve this problem is by adding each clone node into a hash map, into a hash map. We can use a hash map whereby the original node will be the key, while the cloned node will be the value. So whenever we clone a particular node, we add it to the hash map, whereby the original node of the cloned node is the key, while the cloned node is the value. So when next we are trying to clone one of his neighbor, and after cloning it, we are trying to iterate through the neighbors of that neighbor, right, of that node. So we won't just end up in an infinite loop. We will be able to try to check at first if that particular node have been cloned already, that is, if the original node of that particular node exists in the hash map. If they do, then we try to get the clone node, which is actually the value of the original node in the hash map, and then in cases like that, we return that one, instead of having to create it and still create its neighbors and doing that again and again. That will result in an infinite loop. We are now going to the code implementation. You are definitely going to understand what I'm trying to say in the code implementation. Alright, let's go to the code implementation for the graph deep copy problem. So first of all, we'll be defining our graph node that will represent each node in the graph. So, and then it will have an initialization where we'll be passing in the value into it. Don't forget that there are two attributes that are important when dealing with graph node. Is the value of the node. So we're gonna set that to val equals to val, right? So, and then the neighbors. So each graph node will have a neighbors. We have neighbors, not necessary, but is a very important attribute. So even if they don't have, then the neighbor array will be set to empty. So alright, just like you can see on the screen, we have this particular node in our graph. So we have to convert that that visual diagram that you can see on the screen, 0, node 1, node 2, node 3. So we're going to be converting them into code, and what we're just trying to do is create the graph and the nodes. So we create node 0, node 1, node 2, and node 3. Okay, let's see. I think there is node 4. Oh no, there's no node 4, just node 3. So after creating it like that, then if you look at the screen, you see that node 0 actually have node 1 and node 2 as neighbor, and similarly node 1 have node 0 and node 2 as neighbor, and that's how it goes. So I'm just trying to create it in code format, right? So okay, after that I perform a print. So I'm just trying to show you what we are actually working with. We'll be defining a graph deep copy function. So that's gonna help us to create the it's gonna help us to clone the original node, and then we are passing in node 0, which is actually the root node, that we are gonna be using to access every other node in the graph. So, and what I'm trying to do here is that a call to this function is actually gonna process the original node and return a cloned graph node, a deep copy cloned. So, and we just want to print the value of that particular node that is returned. So that's what this place is trying to do, and the return will just be 0, right, if it works well. Why? Because the graph node here also has 0, just like you can see on the screen. This is 0, so the cloned node 2 is gonna be 0, right? It's just the same structure, but there won't be any no relationship between them. They are going to be entirely new node, new connections, new edges, right? So that's what we want to do. So now let's create our function graph deep copy. So whereby we'll be collecting the node, which is the root node, which is a graph node, right? So, and similarly we'll be collecting the okay, I think that's all we need for now, and then we'll be returning a graph node as well, so which is the deep copied one. So now we just want to, let's look for a test case whereby if not node, probably the node is none, the node that is sent in is just empty node or none, so we want to return. Otherwise, let's call the DFS function on this particular node, and we are going to be sending in a hash map that is going to help us to keep track of visited nodes, right? So because when you visited node, don't forget we said for a visited node we don't need to clone it again. So once a node has been cloned, once a node has been visited and cloned, just return that cloned node. So okay, the DFS now we are going to be collecting a node, right? And this is going to be a graph node, right? So, and we're also going to be collecting the cloned cloned map. Let's call it cloned map, which is actually a we are passing in a hash map, not a hash set. So in the hash map, the original node will be the key, while the cloned node, the already created clone node, will be the value. So it's going to be helping us to keep track, and it's going to be making us to be able to access the clone node instead of having to create an entirely new cloned node. Since we have cloned it already, we can just easily collect it. So you're going to see what I'm trying to say now. So cloned map is actually a dictionary, right? DICT. So okay, let me set it to dictionary. So, and here we'll be having a graph node return. So now, if for this particular node that we sent into the DFS, if the node is already cloned, if it is in the cloned map, so we just want to return cloned map of node, right? So instead of having to create it, but if it is not there, we are gonna have to create it. So we're gonna call node, or let's call it cloned node. Cloned node is equals to a new graph node. So where we pass in the node dot value. So this way we are trying to perform a deep copy. We are trying to recreate that node and setting in the node value, the original node value there, but now it is an entirely new graph node that we are creating, right? So after cloning it like that, we want to add it into the cloned map, so that the next time we try to pass the same node into the DFS function, we won't be creating it, we'll just be returning the already created one. So and now we're gonna do that is by saying cloned map of node equals to this cloned node, right? We already set it now. So the next thing we want to do is to iterate through the neighbor. For neighbor in neighbors, for neighbor in node dot neighbors. So we want to iterate through each node in the neighbor. So we are gonna say the cloned neighbor. So we are gonna call it cloned neighbor. Why? Because we are gonna proceed to call the DFS function on each of these neighbors to go and clone them. So DFS of neighbor comma clone, let's set in the cloned map so to it, so that it can keep track whether it has been cloned before or not. So now if it has been cloned before, it's just gonna return the cloned one that is saved in the hash map. If it has not been cloned before, definitely it's gonna create a new clone and return it here. So and what we want to do is that we want to just set it to the neighbors attribute of this newly created cloned node. So we just set the neighbor there as a neighbor, and the cloned neighbor as a neighbor of the cloned node. And after doing that for each and every one of the of its neighbor in the original node, we just want to return the cloned node, right? So that's how we solve this problem. So and then in our print function, we'll be expecting to see node 0. Because here we are trying to print the graph deep copy, so it's gonna be 0, just like we can see here, right? So 0 is being returned. Oh, sorry, not 0, not 0. Actually, in the call to this function, we have to perform place a return. So we don't forget that this DFS function is actually gonna return the cloned node, which should be node 0. One thing is that we are recursively calling DFS, right? So at the end of the recursion is we have something we call the recursion stack. So it will be stacking the recursion. So it's like the last thing first out. So meaning that the very last function that is called will be the one to be implemented before the one that is called before it. Meaning that whenever a function is implementing and then a function is called again, the function we have to pause for the new function to implement finish. So and that's why we can be have this mindset and rest of mind that by the time the whole function is done, the very last function that is going to be done and will be returned will be the the first node 0 that we passed in. So don't forget that what we passed in is actually node 0, right? We passed in node 0, this is it here. So and we'll be expecting a cloned version of that node 0. So that's why this returned clone should be returning node 0, right? And now whatsoever it returns, we are gonna return it again right here. So let's run the function again, and I really hope you understand. So we'll be expecting 0 now. Okay, here it is, 0 is returned. So this is how to solve this problem for the graph deep copy. We have effectively copied the graph that way. Thank you, and I really hope you understand. Right, thank you.